Can you guys all see that okay? Yeah? Great. Sorry, it always confuses me when I'm like presenting over here and yeah, anyway. Hi, my name is James Vivian. I'm a JavaScript engineer here at Shutterstock. I work on the JS platform team. And today I'm here to talk to you about Swagger and our path to it. So yeah, stuff for free, or what I've learned about Swagger, so you don't have to. So yeah, you're obviously at Shutterstock. You're here for Tech Talk, but you may be more familiar with us because of our stock images, like a dog that happens to also look like a chameleon, or this watermelon king? I don't know. Anyway, you know who we are. You're here. So who am I? My name is James. Gone over that at jvivs on Twitter and GitHub. And I've been writing JavaScript since 2007. So tonight I'm going to give you a little bit of the overview of the history of services at Shutterstock. Then we're going to talk about what sort of this Swagger thing is. And then we're going to talk about some sort of issues that we've run into integrating it here at scale and what we've done to solve that. But first, how do we get here? So we have this monolith, this Perl Mason code base that's huge. It's what most of our dollars go through whenever you purchase an image on the site. And it's 10 years old. Who here knows Perl? Who here knows JavaScript? That's what I thought. So we have a problem. We need to get out of this mess that we've gotten ourselves into. So yeah, we have this monolith. Unfortunately, yesterday's convenience can be today's nightmare. Over time, this monolith has become our monster. So with a monolith comes monolithic problems. There's poor separation of concerns. We do have database calls in some of our views. The hotspots in the app are hard to spot. We, at some point, thought it was a good idea to dynamically reload code in the app. And there's just cruft everywhere. And this monolith is in a way a victim of its own success, right? Like it worked for so long with a small team. It allowed them to move quickly. Now we're over 100 engineers, and that is no longer the case. So what's the solution? I'm sure you guys know. Services. Make services out of all the things. So we're trying to kill the monolith right now with services. And we've been doing that for basically the whole time I've been here. I came in late 2013, and at that point we had a Shutterstock.com running on Perl. We had the video premiere and big stock sites running on PHP. And we had, as far as consumer-facing apps go, we had offset.com and music in Node. So just to give you a picture of sort of where we were coming from with our services, we wrote a bunch in Perl, we wrote some in Java, we wrote some in Node, we wrote some more in Ruby, we came back to Perl, and then we sort of started to figure out that Node was an easy way to spin up new services. So you may wonder what happened to our monolith. Well, 3 years later, as far as that's my time here at Shutterstock, we're still not done. But we've gotten closer. Thank you to Node. That's probably why you're here. And we happen to have learned a few things along the way. OK, so services. They isolate change. That's great. Or do they? Are they just another kind of suffering? So they have their own set of problems. And I'm going to talk about some of the ones that we've had here. So discovery. Where do you find these services? Where do I find this stuff? Well, you could look in a code base to say, oh, look, there's this internal host. Maybe that's where the code I need to look at is. Or maybe I should look at GitHub. Our internal GitHub has a bunch of stuff. It's a great place to find basically everything that we've written. Well, it's also a place to find basically everything that we've written. You're looking for a needle in a haystack there. You could go look at Confluence or wikis. Yeah, I'm just going to leave that there. You could look at Jenkins to see what's currently building, or you could look at our deployment tools to see what maybe has been deployed recently. Those are all really, they are places to look, but there are many of them, and that's not great. So to find the right version of a service and what APIs you should be interacting with gets harder with scale. As we spin up services, you can see here this is an n-cubed complexity. It's not fun. Documentation is also a problem. This is because you guys are better at writing code than you are at writing docs. It's just a fact. If you aren't, come talk to me. I have a job for you. So the problems here are where to find stuff, how it's structured, what content is actually there, is it fresh, is it stale, and what words that content uses to describe the service itself. These multiplications aren't helpful, and the vocab problem can be real. This is tribal knowledge, and it's everywhere. It also doesn't scale. Okay, so you found the thing, you found the documentation, now you're trying to use it. Well, naming is hard. It's up there with like off by one as one of the like hard programming problems. Not to mention, things change from language to language. Some of these things you may have seen in the past depending on where you have worked. So Ruby, JavaScript, Java, yeah? Anyone like XML here? I don't really. And it does get weirder. Yeah, you can just throw some stuff in there. And no joking, this is a real response from a service that we have. So yeah, API balkanization, it's real. Orchestrating even the most internally consistent APIs can be painful when the naming conventions don't line up. So you found the stuff, you think you know how to interact with one service. Now you've got to orchestrate those services together to actually show some content. Let me play you the song of my people. So you start with a raw HTTP client, maybe request, maybe super agent, maybe something else you like better. You start using that in your app, and you codify app-specific conventions. Different clients have different interfaces. And then as soon as you've written one of these clients, you then codify those URLs right in your code. So what happens when you want to change it? Guess what? Find and replace. That's also not so great. Refactoring tools don't work so well there. And you want to repeat yourself? You can. So then you move on to writing a client library. You abstract away some of the specific URLs. You spend some, really good developer hours crafting these. It does seem like a good idea, right? Like you get to make it comfortable and easy to use. Well, your client library is most likely incomplete. It's specific to your team or your app. It has patterns, but those patterns may not be consistent inside of the client or with anyone else in the company. So you have a new developer on your team who's awesome in some other app. Guess what? They have to relearn your client library. Business logic, it's code. Business logic migrates up there. All those different APIs that have different interfaces with different names, you want to normalize those to make it easy for your app to use. Well, now you have business logic in your clients. Oh, and you're testing those, right? You have test coverage for your clients? All of them? And it's code, so you can have bugs. And docs. So these usability problems with services, they compound exponentially with scale. Just for the sake of continuing the complexity argument here, as soon as you add clients in, you now have n to the 4th complexity. So does that mean the sky's falling? No, the sky is not falling. These problems with services are an easier class of problems than with a monolith. You have isolation. You have less code. That means inherently lower complexity. You have fewer side effects, and there's less knowledge required to actually change something in a given code base because that code base is smaller. So after all that, that's where we were. And we started doing some research, and we really wanted to find a place where apps could talk to each other, where we could actually find some common ground between these different services and orchestrators. So Swagger, that's what we landed on. What is it? Well, lots of people talk about Swagger in different terms. Swagger is a specification that specifies specifications. It's a data structure that describes data structures. And it's also an open standard that is based on open standards. If you want to get technical, it's a language-agnostic open specification to describe REST APIs in this JSON schema format. It's just JSON. Like, that's all it is. And yeah, so the turtles, they go down. So Swagger is a specification. This is important to foreground. That's the reason why this is the second slide where you see Swagger as a specification. It's really commonly misunderstood. It's not a tool itself, but this ecosystem has tooling around it. Sorry, the specification has an ecosystem of tooling around it. So a Swagger spec can describe most things that are important for an API consumer or producer. It can tell you where things are. It can tell you how to reach those things with your paths and verbs, what data needs to be sent, what security scheme you need to actually use to get them, and as well as sort of how to find them, what kind of data you should expect back. So there's a few versions. We use 2 here at Shutterstock. For some reasons, which I can tell you about. They're sort of boring, but come talk to me afterwards if you're interested. The team I'm on, we're called Raging Hellfish. This is really kind of just for kicks here. You can write it a Swagger spec in either JSON or YAML. YAML's nice for humans. So if you can do it that way. And our convention here is or the convention for Swagger in general is to label the file swagger dot whatever format you're using. So speaking of sort of establishing some common ground here, let's all speak the same language. Yeah, you get it. Swagger's the specification. The Swagger spec describes the API. Cool. This can be confusing. You'll often hear people talking about doing things in Swagger. I may be prejudiced here because of my background as an English major, but use the right words, it really helps. So there's a few common concepts in a Swagger doc, and I'm going to sort of go over a few for you. So a schema, like a Swagger spec is a schema. This is just a way to describe data. This is a base structure that's used in many parts of the spec. You can describe most things. From primitives, arrays, objects, all the stuff you're used to in JavaScript. There are more complex data types, so it's good to know about them. Again, I'm talking to you about a spec. Go read it if you're really looking for all the details here. But these are sort of some of the high-level things you need to know. And yeah, so the paths object, you can imagine this is the router for your spec. So this describes all the different locations that your API wants to expose. You can actually turn this into a router with the Swagger tools library. It includes a piece of middleware that racks up routes based on this data structure, which is kind of cool. We'll talk a little bit more about that later. So an operation, you may think of a route as an atomic thing, but there's actually the combination of the HTTP verb and the path. And this is so Swagger uses the term operation to describe that unique combination. If you are writing a spec and you want to use it and want to consume it via client or with generated clients, make sure to specify an operation ID. That'll make your client a lot nicer. It's sort of like the unique identifier for that combination of HTTP and verb, and that'll actually be the method name. So do that. It's good, and you'll be nice to other people who are using your APIs. So these operations, they take parameters. Again, we're all used to this, but this is, yeah, you do need to know the terminology. So this is all parts of data that can be passed in to an operation. It's not just the query params. So some of the data that can be described with parameters in Swagger, in addition to query params, you have the path templating. So you can extract data from your path itself. You can specify headers. You can describe the body content. You can also describe files. So Oh, and yeah, definitions. So this is a really great way to improve the readability of your spec. If you don't use these, your spec ends up being a lot of lines, and your fingers will probably be tired. So you can use a ref and reference a different part of another Swagger document, and that saves saves you a lot of time and saves someone else if they're trying to actually understand what your spec is doing. So here's an example of one. Say we had a tag with an ID and a name. Super simple, right? So this would be the definition to actually describe that. So you can see it's an object that has properties, one of which is an ID, that's an integer. The other is a name, which is a string. Pretty simple. And these reference objects are, so you can reference these definitions in other places in your docs with this ref property. And these references are actually pretty close to URLs. So here's some examples. This one probably looks very similar to an anchor tag. This refers to a definition or within the actual file that you're using it. This references an entire different file. So this can be useful for schemas or sharing things across different specs. Then if we put it all together, we can actually reference fragments in another document. Yay. So when you have an API, you probably need to authenticate something. Swagger supports most common forms of authentication. There are caveats that I'll talk about later. Ultimately, when you're specifying these things, you're really just describing parameters, but they're special parameters. So when describing them, you want the names to match. This is something that we kind of had to actually play around with and figure out. So on a given, like a given route, you need to make sure that the contributor the contributor security definition includes information about, includes information that says the user can view something. So on a route, you'd specify the security, and on the spec itself, you'd actually define that security definition. Okay, so some other useful stuff I learned. There's this cool editor online, editor.swagger.io. Interestingly enough, response descriptions are not optional. This is a good thing. You want to tell people about the kind of response you're sending them. And Swagger specs themselves are extensible. So the tool that we use internally for routing is actually an extension on top of the Swagger spec. You'll often see, if you go consume someone else's Swagger spec, you'll see that extended with the x- prefix. Again, this is all in the spec. I'm just giving you guys the highlights here. So what makes a spec well written? Ideally, you want to factor out common structures. Again, reuse those, write some definitions, use them via refs, and add descriptions. Descriptions are the things that that's like a place that you have to actually describe what the thing is that you're trying to do or that you're trying to return, or the data structure involved. Okay, so you know what this thing is. Why do you want to use it? Can anyone think of a reason why you want to use it? Raise your hand if you can. Okay, I have one. Okay, let me help you out here. So the first thing that most people think of is, oh, documentation, great. I have a way to make my documentation consistent. So there's this cool app that the Swagger team, or that some Node devs wrote. It's called Swagger UI. This will actually take your Swagger doc and turn it into interactive documentation. Who here has interactive documentation? Nope, not even you. Okay, so it's consistent across all specs. If you need to find something and you're familiar with the structure of Swagger UI, you can probably parse a new spec pretty quickly. Also, you get it for free. You don't have to build it. But Swagger is more than just docs. When you use routing validation, when you do routing validation, security and ACL middleware, when you generate some clients, you can actually also get into generating your database models and automating your API testing, all because you have this document that actually describes your API. So some libraries we use with Swagger. Swagger tools, we use this for scaffolding out APIs. This is if you're writing an API, this is the place you want to go, at least to start. Generate your docs with Swagger UI. Use Swagger client to generate your client. And then there are other teams here are also using read YAML to take YAML and parse it to JSON and feed it in, because they find it much easier to read. Okay, so now you understand why you may want to use it, but why is it important? Like, you may think, okay, great, it's just a JSON file. Well, at its core, the Swagger spec carves out a common ground for both computers and humans to understand REST APIs. With these common terms, we can write and reuse tools and libraries across APIs in diverse languages. So it's not just Node. Anyone in any language can write something that will consume a Swagger spec. So this establishes a garden of the commons. I know this is like a little touchy-feely, whatever, but when we actually use these documents to map routes to controllers, parameters to validations, a Swagger spec can become the canonical representation of an API. And just like a REST API establishes a contract for, or sorry, just like a regular API establishes a contract for interacting with a library, a Swagger spec establishes a contract for interacting with APIs in general. And within this common ground, engineers can spend their time crafting APIs and tools that work together regardless of platform or language. Good to know that Swagger is now called OpenAPI, or rather OpenAPI now owns Swagger. It's a little confusing. Probably one of the two things I just said is correct. One of them is wrong. But on January 1st, it was donated to the OpenAPI initiative. You may recognize some names on this list. But it is under the, it is a Linux Foundation collaboration project, just like Node. All right, so we rolled out Swagger. It's actually been pretty useful in terms of scaling up the number of teams we have running on Node, both orchestrators and APIs. But we found some issues, and we've come up with some solutions, or at least some plans. So some of the problems we have here. There's a learning curve and context gap around Swagger. People don't often understand what it is or how to use it. There's also a mismatch between perceptions for the person writing a Swagger spec and someone consuming it in an orchestrating app. It can also, just like regular services, it can be hard to find and it can be hard to distribute. So we've done some stuff to make that easier. Security definitions are a little bit of a pain right now, but in a way, like, something you just kind of have to learn. There's some production issues too, and then I'll talk some more about the tooling. So learning curve. It exists. Fear of the unknown is real. When you talk about Swagger and someone doesn't know what it is, they kind of freak out a little bit. And it's really easy to spread confusion about an abstract idea. So what do we do about this? Well, we talked about it. We explained what Swagger is. It's important to differentiate, like I said before, the specification from the tooling around it. We talk about the problems it solves and talk about them clearly. Then do some work and talk some more. Share some good spec examples. Find some, try to write one yourself. Have some working sessions with other developers who are actually like sort of struggling to implement this kind of stuff. You may learn something from them that you didn't even know. Give internal tech talks. The reason why I'm talking to you now is because I gave one. Hang out in a Slack channel. Let people talk about things. Have them propose solutions. Collaborate on stuff. And then, like, once you're ready, give a team the power to actually lead the charge. Let them work with this technology and roll it out across different services. You may get some pushback, but ultimately, in the long term, it's worth it. Yeah, so the more you invest, the better your return. The docs are great, but the real value comes when you actually start to use the spec for more than just docs. So our mismatch between author and consumer. Authors care about their app, just like you care about your code, not so much about the docs. Your consumers do care about your docs and your clients. So how do you fix this? With some communication and expertise. Some ways to do this that we found helpful are actually highlighting some business-specific concerns. So talking to people about what problems you're actually trying to solve internally in your company and how this technology does it. Open up that process. Don't don't do this in a back room because someone's going to complain about it. Someone's going to say they didn't have input. Put it out in the open. People will also talk about WSDL and SOAP. Swagger's a little bit better. It actually does seem to solve a lot of the problems. Pair with people, like sit down, work with them, experience their problems, express some empathy, and then learn from it. If you can, implement validation. It's way easier to have a machine be the bad guy than a human. So, okay, discovery, again, just like services, you actually have to be able to discover your Swagger specs. A spec is useless if you can't find it. So what we did is we aggregated our specs into a simple app. Let's see. I had a demo here. Can I click over here? Yay. This is our internal Swagger specs. It's not that pretty, but it works. Let's see. I don't know what I'm clicking on here. Oh yeah, there you go. There's our settings service. So this is actually a docx-lite generated from a Swagger spec. Let's see if I can actually get back to my presentation. Yay. So that's just a really simple Express app. We digest a repo that's filled with Swagger specs and auto-generate that. I think it was maybe 15 lines of code. We probably should open source it. One thing that's worth noting is that most places with Node, you don't want to use the stars for Semver. This is one place that you do. You always want to display people the most up-to-date version of your docs. So yeah, distribution, how do we get it? How do we actually get these specs and clients into people's hands? Well, we put them in one repo. We're working on ways to make this better right now, but we have a little bit of automation around adding hostname. This solves some of the problems of actually having like dev, QA, prod, and having to code that manually. I think we use ES6 template strings. Yay. And yeah, publisher specs as a module, so someone can actually reference the version in their package JSON. Make machines do the work. I know, like, I keep sort of coming down on this, but like make the machines do the hard stuff or do the boring stuff so you can do the interesting stuff. So as you can imagine, we've run into some issues as far as actually deploying this into production. We found that Swagger tools, the router in there mounts to root, or it wants you to mount to root. It's non-standard in Express, and things like New Relic don't really have a good time with it. So we actually manually tack on the route to, let's see, I think I have an example here later. But we tack on the URL to the actual New Relic agent, which helps. Swagger client, the library is a little weird. It is asynchronous, so you'll actually get the client back, but it won't be ready until it calls like a jQuery style complete method. You'll see this in some of the other tooling in the Swagger ecosystem. They follow patterns that aren't necessarily sort of first-class JavaScript. So we've wrapped it as a short-term solution. In the long term, we're actually looking to contribute back upstream and fix it and make it nicer to use. But there is a little work to do there. Code generation, so these clients that you get are generated. It's not cheap to do that. It's not terribly expensive, but it's also not cheap. So we reuse our client across multiple requests. That's good, but there's some caveats with that, especially around security definitions, which I'll get to in a little bit. So the Swagger client library itself is designed to work with Swagger UI. So this is designed to fetch specs across the internet. That's not so great when you're trying to spin up a service, and maybe the spec you're trying to read is from a service that's also trying to start up, and you maybe 404 that. You 404 the request for that Swagger spec. It's not documented, but you can pass a spec as a file, as a JSON file. That's what we do to actually make our builds reproducible and a deployable artifact. Oh, here's that middleware. Sorry, that slide's out of order. So this is, again, I'll just shoot this to you if you're interested in it, but the TLDR is that we tack on the URL and tell New Relic what's up. Yeah, so these security definitions, this is probably the roughest part of the spec. It's because authentication is complex. There's multiple ways to do it. But if you're using Swagger clients, these security definitions apply per client, not per operation. So if you're in Node and you want to reuse a client and not generate a new one every request, specify whatever method you're using for authentication as a parameter. This will make it so that you don't have to keep generating new clients every time. So we had some issues with the tooling. Swagger itself isn't new, but the tooling isn't mature either. No surprise here, but this is what you guys are here for. You can help out. So solutions to some of the tooling problems, read the source. It's actually not terrible. And then can contribute some code upstream and maybe write some docs, because I sure would like it. So okay, that's what's happened here. What are we looking for in the future? Where do we go? We're going to be contributing upstream. So improving the tooling is really helpful to actually make this, to help this spec get some life and get some legs. There's some big names that you saw earlier on the people who are already adopting it, but improving the tooling will actually make it way easier for smaller people to use too, or for smaller companies to use too. It also will help to break some of these larger libraries down, and you can write some cool new stuff because that spec is pretty consistent. Use Swagger client. It's the best one we found in JavaScript. It's primarily targeted for the exploration of APIs, not actual prod consumption. So we're thinking about ways to actually make that better. Spec generation. Writing these by hand isn't the most awesome, but there could be some more tooling around that to optimize both in terms of legibility and code reuse. If someone who's like really awesome with abstract syntax trees wants to dig in, let's talk. Because I think that's really one of the few ways that you could actually generate a Swagger spec programmatically from JavaScript. Validating your spec. There's a Swagger parser out there. There's a few other validation tools. It's not great yet, but we hope to make that better. Automating spec cleanup would be really great. So basically being able to take a generated spec from sort of a Java client, or sorry, a Java app, and take that fully dereferenced spec and compress it down into something that's actually nice to read. Finding other specs. We put up an internal site, but there are ideally a lot of these out on the internet. So it'd be great to find, or to have a place where you could go to find them, just like you have for NPM to find other modules. I think Apiary is working on this, but there's more work to be done there too. Documentation, please write some. It's a really great way to get involved with open source and also to learn about a project. People are really happy if you want to write their docs for them, it turns out. Anyway, so that's Swagger. Thanks for sticking with me. Thank you to originally Nodejs for the opportunity to make this talk. Thank you to New York Nodejs for letting me giving it again. And yeah, thanks for Shutterstock for giving me the time and support, and the other people on my team for covering for me while I did this. Thanks to Photios for the LaTeX. Yep, and thanks to you for paying attention. Yeah, so it is similar to describing schema in Mongoose, except that instead of just your app and Mongoose consuming it, everyone else who's actually interacting with your app can consume it. So you can generate docs from that. I mean, you could do all the things. You can cut down a lot of the code that you'd write in your app beyond just sort of generating some data structures. But yeah, you're getting it. Yeah, so the question is, does this, in spite of me saying use it for everything, does it actually have value if you're dealing with a monolith or you're sort of trying to get started? The answer is absolutely yes. Having something is better than nothing. And once you have, say you're using Swagger to describe part of your API, and it comes time to actually take that chunk out of your monolith and spin up a service. Well, guess what? You now have a spec to describe that service. That description isn't going to go away as long as it stays up, as long as you keep it up to date with your code. And when it comes time to actually break down a chunk of that monolith and put it somewhere else and isolate it, you now have a router validation and a client for that service just by writing that spec. So the question is, given the fact that we have a repo with all of our Swagger specs in it for our documentation, when do we update it, before or after the release? Right now, we update the repo. Again, this is something we're working on, but we update the repo. We basically ask people who are authoring specs to pull requests against the repo for the clients, or sorry, for the specs, and those specs are then in turn consumed by the docs repo and by the client's repo. So we ask them to do it once they're about to go to prod. The nice thing about it is if someone wants to just update their spec in dev, they can. I don't know if you probably missed the URL for that site, but that's actually an environment-specific documentation site. So you can go and actually read docs for a given environment if, for example, someone's rolling out an API change. I would also recommend that someone version their API, so you could actually check out a different version, and then once that version's ready, then you sort of communicate to everyone else, hey, the new version's out, it's good to go.
Is this on? So you mentioned that you guys have clients that are consuming the Swagger spec to make API requests against it. And then you also mentioned, I think, that your routers are generated based on the Swagger spec.
Yes.
Have you guys tried going the reverse way where you have existing code and you want to build auto-generate Swagger spec for it? And have you encountered issues, and how do you get around those issues? So we have a Django application in my company, and we tried to auto-generate Swagger, and then bad things happen as soon as you have custom business logic. So.
Yeah, so JavaScript's a dynamic language. You can use, I think there's some like JSON doc generators if you write your JSON docs in just kind of the right way. There are generators, I know, for Java as well as other statically typed languages. Unfortunately, auto-generating Swagger spec from a dynamic language is hard. That's why I was sort of fishing for someone who knows about abstract syntax trees. Because if you can actually, you might be able to solve the problem with something like that. But right now, I mean, you could do router introspection. You know, start up your app, grab your router, and you could at least dump the paths so you could get something going. But if you're doing anything in your middleware, or if you're mangling any, or if you're like, not mangling, if you're interacting with any of your params or rewriting them on the way down, it's really difficult for a generic tool to parse that, unless it's actually looking at the structure of the JavaScript itself. So unfortunately, no.
Is there tooling available for other languages? Like if you want to generate a client in, say, Java or anything else aside from Node?
Yes. So the question was, is there tooling available for other languages? There definitely is. I think Swagger started as a way, I think the first class client is a Java client. And I know there's clients out there for Python and Ruby and Scala, among others. But yeah, if you go to swagger.io, which I should probably actually have in the presentation, they list out a whole bunch of the clients that are currently published and a bunch of other tooling around in the ecosystem.
did you find any other alternatives? I can see the killer features of the documentation. We all love that because we're all scrambling. We're doing exactly the same thing you're saying, trying to keep it roughly intact with what we've already written. Was there a second place to Swagger? What was next?
As like a specification, or in terms of
as something to generate the documentation, because I think that's what we're hearing the killer feature is.
I mean, you can, if you want to write JS docs, you can. I don't like to that much. I like to try to make my code nice. And again, like, I'm a developer, I want to write the code. I don't necessarily want to write the documentation. The first selling point is the auto-generated docs, but you really do start to see a lot more value across your institution if you embrace multiple uses for the same document. So, yeah.
Okay, no second place then.
No, I mean, there really wasn't, I think, oh man. RAML, yeah. Someone brought up RAML the last time. I guess Swagger 1.2 was very different, or was more different than Swagger 2.0, and like someone who's more familiar with RAML mentioned that the Swagger 2 sort of ripped off RAML, and now the Swagger ecosystem sort of has a lot more weight and energy behind it.
All right, thank you.
Any more questions for James? All right, let's give him a round of applause.
Thanks.